I wonder if we have a KSP lab.
Well, funny you should say that, Mr. Moore, because we do
Oh.
have a KSP lab. I know that's putting a smile on all our students' faces as well.
Mm-hmm.
Yeah. Yeah, this is, well, you can see up here, we're trying to use a titration to determine the silver ion concentration. But the way you have to think of this is, the silver ions are being created by this sparingly soluble salt, Ag2X. Right, so you have to realize that, you know, Mr. Moore and I took a bunch of this salt, Ag2X, dumped it into a beaker, stirred it like crazy, let it sit for a long time, developed the equilibrium, and then we poured off the solution to be titrated in this lab.
Mm-hmm.
Right, so you're actually titrating the silver ions that are in solution, but those silver ions came from this salt Ag2X. And there's a lot of possible identities for X. X is some -2 ion. It doesn't matter to you who X is. Right? That is not part of this at all. You're just ultimately trying to find the KSP value for this salt. Okay?
Mm-hmm.
So now, here is the titration reaction. Okay, we're going to put some thiocyanate into the burette. Okay, and of course, whatever's in the burette, you have to know the concentration of, and it is 0.0100 molarity. And so, the silver ion and the thiocyanate ion get together to make AgSCN, which is a white precipitate. So what you have to be able to do then is know where's the end point for this, right? When have I added just the right amount of when have I added just the right amount of thiocyanate to match the moles of silver?
Mm-hmm.
Okay, so we're going to use an indicator to help us with that. All right, now the thiocyanate makes a white precipitate. So if you go past the end point, the farther and farther past the end point you go, you know, you're seeing this white precipitate, but what you want to know is when do these moles equal each other? And so to use as an indicator, we're going to have iron +3 ions. Okay, now this is a different reaction. This is the indicator reaction. The iron +3, that is our indicator, when it reacts with SCN -1, it makes this ion that has a red color, kind of a brownish red color. So the whole idea is you start out with your saturated solution of Ag2X that has a silver ion in it. We'll measure that out. We'll put in 6 drops of the indicator, and we'll start to titrate, okay? And so the silver ion and the thiocyanate ion, they get together to make the AgSCN. That happens first. But as soon as all the silver's been used up and it's gone, then the iron that's there reacts with the thiocyanate to make this, and you start to get a red color. It's a little bit of a tricky endpoint because you'll see it's going to sort of look like a milky white color from the AgSCN. We're looking for when that first hint of red starts to show up. So it goes from being white to kind of a dingy red color. It's a little bit of a tricky endpoint. But as soon as we see this red showing up, that tells us to stop titrating.
So the silver and the iron will be in there together. The silver gets together with the thiocyanate preferentially before the iron will. So we'll use up all the silver and then the iron gets its chance to react.
Right, that's right. It's kind of like a battle for thiocyanate between silver and iron. Silver wins until it's gone.
Until it's gone.
And then the iron is left to react.
Okay, do you have that concentration of thiocyanate?
Yep.
And let's go run this titration.
Run some titration.
Last titration of the year, Mr. Hubble.
I believe it is.
Yep.
Normally I have Kleenex out because students are crying.
Yes, I know. Say goodbye to the burettes. It's a sad day. Solution 3 of the Ag2X.
Yep.
And Mr. Hubble, looks like you've measured out 10 ml of that solution?
Yep, we've got 10 ml, 10.0 ml of Ag2X. Remember, this is a saturated solution of Ag2X. Okay, here's our indicator, iron +3. And we've learned over the years that 6 drops is about the right amount. 1, 2, 3, 4, 5, 6 for the indicator. And we're ready to go.
Uh-huh. So we have reloaded the burette. It's at 0.0 milliliters.
And as we start to titrate, it's going to look white again. You're going to see the white precipitate because of AgSCN.
We've already run this thing once, and we've gotten an
Right.
idea of how much it's going to take.
Right. We've got a ballpark idea here. Notice it looks kind of milky white. That's the AgSCN. But when the silver is used up, we're going to start to see some red appear. It'll look kind of like a dingy white color. And let's see where I'm at. I should have to go a ways more. Started looking clumpy.
Mm-hmm. I think you got the brown.
For sure. Now,
Yeah.
for sure now it looks brown.
Uh-huh.
Now, I don't know if I went past.
Yeah, this is a case where it's good to run another trial, I
Yeah.
think. We may just run another trial and throw the first one out.
Maybe.
Yeah,
I was going by our first trial, and that's
okay.
probably went a little longer than I should
Okay.
have.
We have Mr. Apple put his hand up there so we can see the markings. Come on, there it is. Maybe. Okay. Make sure you read the burette to the hundredths place. Okay.
Okay. 10.0 milliliters. Ag2X. 6 drops. 1, 2, 3, 4, 5, 6. Okay. I should still be looking milky white there.
Not quite as white as the paper that's next to it, but
Yeah, I don't.
yeah, it's still white.
That's quite a bit less than I used the first time.
It's not white anymore.
It's not white anymore. You might almost have to run a third one, do you think?
Yeah, I think that's at the end point, or close to it.
Okay, let's try one more.
Yep. Okay.
Doesn't take too long to do. So.
Oh, we didn't read the volume. I'm going to come over here around you.
That would have been bad.
Yeah, let's make sure we get that. Okay.
No milliliters. 6 grams. 1, 2, 3, 4, 5, 6. It starts to look clumpy. You're getting
Mm-hmm. Yeah, you see how
close.
it's gotten chunky like that? Mm-hmm. I'll go with that.
Okay. All right, look at it here. It still looks white.
All right. Cyanide concentration.